In this video, we're going to review concentration and dilution, which I always like to relate to Kool-Aid because that's a solution in our everyday life that most people have encountered and can understand what we mean by concentration and dilution. So a concentrated Kool-Aid has a lot of sugar. You can taste that it's concentrated. If you have like healthy family or something that water down their Kool-Aid, you can tell that it's not as sweet as the concentrated Kool-Aid. If you think it's too sweet, what do? You add some water to dilute it and make it less concentrated. So scientists use the unit of molarity to define the concentration of a solution. So relating back to Kool-Aid, if I'm making 4 liters, which is about a gallon of Kool-Aid, typically, that was weird. Typically, you use about 80 grams of sucrose. And that includes what's in the packet and like the 1.5 cups of sugar that you add. The molar mass of sucrose is about 342.3 grams per mole. I want to know the molarity, the molar concentration of that Kool-Aid, which is in moles of solute per liters of solution. So there's 2 things I have to do. First, I have to find the moles of our solute, which is sugar. How do I find moles if I'm given grams? We use the molar mass of sucrose and divide. So dividing 80 grams by 342.3 grams per mole, grams is going to cancel out and we end up with moles as our unit. So I have about 0.233 moles of sucrose. Second thing I have to do is divide it by the liter or volume of the solution. In this case, I have 4 liters, so I'm dividing 0.233 moles divided by 4, and I get 0.058 molar. So we represent molarity, moles per liter with a capital M. Capital M just means moles per liter. So that's the concentration of my Kool-Aid. If I want to make it more concentrated, I can do one of 2 things. I can either reduce the amount of water or the amount of the liters of solution that I am making. So if I use 2 liters instead of 4 liters, still 80 grams of sugar, so still 0.233 moles. This time I'm dividing by 2 liters and I get 0.116 molar, which is clearly greater than 0.058 molar. But I could also add more sugar if I wanted a more concentrated solution. So if I use 100 grams instead of 80, still using the 4 liters of solution total, I get a 0.073 molar solution. So less concentrated than if I halved the volume of solution that I'm making, but more concentrated than my original solution. But usually in science, in labs, what we're doing is actually diluting things, which we will get to in the next slide. Molality is a second unit that's used for dilutions, but in AP Chem, we don't really worry about it too much. We're just going to be focusing on molarity because most solutions that we make for AP Chem in terms of the exam and questions use water as a solvent. For water, molarity and molality are essentially the same value, so that's why we focus on molarity. It's the more common unit that we're using. Scientists use molality because it doesn't change with temperature, because molarity will change with temperature. Molality does not. The only difference, well, there's 2 differences really, but they are both in the denominator of our unit. We still have moles of solute on top, but instead of liters, we're using kilograms, and instead of solution, we're just focusing on the solvent. So again, water doesn't make a huge difference usually, but typically in AP Chem, we're going to be focusing on molarity. So for the calculations, we're going to be focusing on molarity calculations, not so much molality, although it might come up again. But again, scientists typically are diluting solutions more than they're making them more concentrated. So for example, when I order chemicals, typically it's a more concentrated solution than what I'm looking for to work with in the lab. So I will typically dilute those from those stock solutions, and that means I can use that stock solution over a longer period of time because I'm diluting it into a different concentration. So typically we dilute by increasing the amount of solvent. We don't change the number of moles of the solute. I'm not taking out any particles when I'm forming a dilution. I am simply adding solvent. So if the moles are staying the same, I'm adding solvent, which is going to change the volume, which is going to dilute, make a lower concentration of the solution. We can always calculate how many moles of solute I have by taking the concentration times the volume of the solution. So if you think moles per liter times liter, liters are going to cancel out and you end up with moles of solute. Because the moles of solute aren't changing during my dilution, I can calculate either a new concentration that I'm going to be making given a volume, or I can find a volume that I will need given the concentration I want, which is typically what I'm doing in the lab. So that equation to solve for this is M1V1, original concentration, molar concentration, times volume, typically in liters, equals the new concentration times the new volume. This volume is the volume of the solution, not the volume of just the solvent. So for example, I know I have this in my cabinet because I just unpacked my room yesterday. We have 3 molar sulfuric acid. I don't want to use that concentrated sulfuric acid in a lab, so I'm going to dilute it to 1 molar. And to start with, my original volume is going to be 5 milliliters of sulfuric acid, so that's how much of the stock solution I am using. How much water do I need to add to make that 1 molar concentration? So here, I stay with milliliters. As long as you use the same unit for volume, it's fine, because if we were to convert this to liters, I would end up just converting this back to milliliters anyway, because it's not going to be a point to measure it in liters. I will have an instrument with milliliters, so that's why that volume is in milliliters and not liters. Long and drawn out explanation. But here, my original concentration is 3 molar of my stock solution. My original volume, I haven't added anything, I'm just using 5 milliliters of that solution, is 5 mils. I want a 1 molar concentration. So how much water am I going to end up adding? That's not what the question mark is. The question mark is, what is the volume of my total solution after I have diluted to 1 molar? So just be careful of keeping in mind what that X or question mark actually means. So if I solve, 3 times 5 equals 15, divided by 1, I solve for the question mark, which is 15 mils. So my new V, 15 mils. So how much water do I add to 5 mils to get 15 mils? I add 10 mils of water, okay? So again, remember this V is the volume of solution, not how much solvent I'm going to be adding. If I add 15 mils of water, my new volume is not 15 mils, it's 20 mils, because 15 plus 5 is 20. So again, I want to add 10 mils of water. So what I would do in the lab to do this is I would get a 15 milliliter volumetric flask. This is what a volumetric flask looks like. It is a very precise instrument, but it's only precise for 1 volume. This image is only precise for 10 mils. So I want one with 15 mils, which I don't even think I have one of those, but I'm sure they make them. And I would be using a 15 mil volumetric flask. Again, probably the most accurate instrument you have for making a solution. So I would add some distilled water to the flask, just enough to like coat the bottom, maybe give you like a ½ inch of water. Then I would add my 5 mils of sulfuric acid, which I would use with a pipette. I would add those 5 mils, and then I would fill with distilled water to that line on the volumetric flask, which is, in my case, 15 mils. In this image, it's a 10 milliliter volumetric flask, so that would be 10 mils. So the reason I put in water and then acid and then fill again with water is because of lab safety. You never add water to acid. You add acid to water. Reason for this? If while you're pouring it, some acid would splash out, it would be more dilute if you had added it to water. If you are adding water to acid and you get some splashback, it's more concentrated in acid, and you don't want acid in your face. Never a good thing to have any chemical in your face, really. But less concentrated acid would be preferable to more concentrated acid, which is why you always add acid to water. The other thing is it is typically an exothermic reaction, so that also gets really hot as well. So that's why I add water, then acid, then water. This was a question on the AP exam, I think 3 years ago, if I remember correctly. But you had to describe how you would make a dilution. So you had to show this math, and then you had to describe the scientific practice that you would use to actually do that dilution. Most of the kids on that test didn't add acid to water, they added water to acid, so they didn't get that point on the exam. So safe lab practice is always important. So that is our review on dilution and concentration. Let me know if you have any questions. These are all topics that we will go into more detail throughout the year. This is just kind of refresh some memory, hopefully, of what you learned in Chem 1, whether it was last year or 2 years ago. So I don't expect you to be experts yet, but I'm just hoping it brings back some fine memories.